Look up into the darkness and you'll see a sky filled with ancient lights, steady and eternal. But the longer you watch, the more the illusion cracks. Some stars pulse slightly. Others shimmer as if breathing. A few seem to shiver, flicker, or dance. It feels alive, almost magical, and yet the question remains, why do stars twinkle at all? The answer begins billions of miles away. But the true cause is much closer than most people imagine. When starlight leaves its source, it is steady, straight, unwavering, perfect. It travels across a vacuum that offers no resistance, no distortion, no turbulence. A star's rays move through space with quiet precision, unbroken by anything for unimaginable distances. If you could ride alongside that beam of light, it would appear perfectly smooth, like a straight line carved through the universe. But something changes the moment that ancient light reaches our world. Earth's atmosphere, the thin envelope of gases we depend on for life, is never still. The air shifts constantly. Warm pockets rise, cool layers fall. Invisible currents twist in slow spirals. Even when the night feels calm, the atmosphere moves like a giant, transparent ocean. As starlight passes through these shifting layers, it bends ever so slightly, sometimes multiple times in a single instant. These tiny distortions change the apparent brightness and position of the star by just enough for our eyes to notice. The star seems to flicker, wobble, or pulse. In reality, the star remains perfectly steady. It is the air in front of us that dances. We are watching the atmosphere reshaping light, creating a shimmering effect that has inspired myths, poetry, and wonder since the beginning of human memory. This effect becomes even clearer when you compare stars to planets. Planets don't twinkle in the same dramatic way. Their light reaches us not as a fine point, but as a small disk, wide enough to average out the atmospheric distortions. A planet's glow stays consistent, smooth, and calm. A star, by contrast, is so far away that its light collapses into a single pinpoint, making it far more vulnerable to the restless waves of air. Twinkling is a sign of distance, a clue that the object you're viewing lies far beyond our solar system. But twinkling does more than enchant the eye. It can actually tell astronomers something about the atmosphere itself. By studying the flicker, scientists can measure turbulence, temperature variations, and even predict weather patterns at high altitudes. In a way, every twinkle is a message about the air we live in, written by the universe and interpreted on Earth. If you traveled above the atmosphere high into orbit, where the air thins to nothing, the twinkling would vanish. Stars would hang in absolute stillness, sharp and unwavering. Without the atmosphere, starlight would reach you exactly as it left its source. Pure, direct, unchanged across time and space. Yet the twinkle gives the night sky a character all its own. It reminds us that we live at the boundary between Earth and the cosmos. The flicker of a star is the meeting point of two worlds, one ancient and distant, one living and dynamic. It is the universe filtered through the breath of our own planet. So when you stand beneath the night sky and see a star shimmering softly, know this: the star itself is steady. The twinkle is Earth's fingerprint, a gentle distortion shaped by the air that makes life possible. And in that shimmering light, you witness a quiet dialogue between the heavens and the home you stand on. Be sure to hit like and subscribe to the channel to learn more answers to that awesome question, why?